quick lecture on the public land survey system. You all already watched the Kaltura video, so you're probably familiar with it. The slides in here are taken directly from that. Mike talked a little bit about some of it at the beginning of class, and then at the end we're all going to do an exercise. So you're going to use the same tools that we talk about in here in the exercise. So in the beginning, in the 13 colonies, we had a different surveying system. Mike mentioned it in the beginning of class. Does anyone remember what it's called?
Meets and bounds.
Meets and bounds, yeah. So they used meets and bounds. And so with meets and bounds, there were landmarks, like witness trees. So you might have something like from the large boulder, go northwest for 300 feet, and then bring you to another landmark. And by connecting all those landmarks with directions and distances, you could make a closed traverse there and describe a property. So, but then when we purchased the Northwest Territory, it was a substantial amount of land, and Congress decided that they wanted a more efficient way of kind of mapping, surveying this land. So they came up with the Land Ordinance 1785 and the Northwest Ordinance in 1787, and that's when township and range really came into use. And so what the township and range does is sets a two-dimensional planar grid onto the Earth's surface, which we all know isn't actually two-dimensional. It's a geoid, and so we've talked about in class some of the challenges that presents, trying to set something two-dimensional on an object that's not actually two-dimensional. And so they set up townships and ranges, right? So what we're looking at here, this all collectively, 1 through 36, that makes a township. And each of those numbers individually, 1, 2, those are each sections, right? And so a section is 1 square mile, so it's a mile on each side, right? And so a township has 36 of those. So you've got a mile, a mile, a mile, a mile. So on that side, 6 miles, and then on this side, 6 miles. So what's the total area of a township going to be? 36, yeah, 36 square miles. Nice. And so now that you kind of have this unit that you're looking at, you need an initial point. It works kind of the same way as a reference point, right? So when we're taking a bearing or an azimuth on our compass, that direction is relative to a meridian, right? We use that north-south line. You need something to use as a reference point. And so with these townships and ranges, we have the same thing. We use a meridian as a reference point. And so where that meridian, that north-south line, crosses with a perpendicular, what we call baseline, that's an initial point. And so from those initial points, then we start to describe, okay, where are these townships in relation to this initial point? So we'll look at some of the initial points. This is the 6th principal meridian, right? And so where that's crossed with this, that would make an initial point, right? Up here, we have the Willamette meridian, so we'll look at that a little more closely. So here's Washington, Oregon. This north-south line here, a meridian, that's the Willamette meridian. It's crossed by a baseline, right? So we've got our initial point. And so this is the actual initial point, right? So you can actually see there's this little crosshair right here, right? And at the very middle of that's the initial point. It's that accurate. And so you're going to use that as a reference point to describe where these townships are. And so here's kind of the grid system that we lay in with this township and range position, right? So here's our principal meridian, right? And here's our baseline. And you'll notice, so what's a meridian? So it's, Andrew?
Like a middle line.
Yeah, so it's any line that runs north to south, right? Yeah, so we have lots of lines that run north to south, right? All of these run north to south. But there's something special about the principal meridian, and that is that it's continuous through this area. You'll notice some of these other lines, they're kind of disjunct, right? They don't continue all the way through. And so that's a feature of the fact that we're applying this two-dimensional system onto something three-dimensional. We have to kind of correct for that. But we use these principal meridians as kind of, those are our references, and we allow those to be continuous through the area. And so from this initial point, we're going to describe some locations, right? And so here is Township 3 South. And so our townships are actually east-west lines, right? So east-west. And so for this township, we move down 1, 2, 3. So the township is 3 south, right? And for our range, there are these north-south lines like meridians are. So we have to move over 1, 2, 3 over, right? So 3 west. So that would be how you describe this location, this township here. Township 3 south, range 3 west, okay? So does anyone have any guesses on how you would get to, how you would describe this location? So let's start with the township, right? So the township, we have to move in this direction, right? So here's township 1 north, right? So what do you think the township would be? We've got 1 north here, 2 north, 3 north, yeah. And so our range, we have to move over 1, 2, and what direction are we moving? East, right? So it'd be 2 east. And then here's one a little further away, right? And you start to notice that these disjunct meridians start to come into play here. And so the easiest way to not get into a weird situation with those is first do your township, right? So we're going to move up 1, 2, 3, 4, 5, 6, 7, right? And now you see we can move over clean over here, whereas if we had gone that 7 over here, then you get in this situation where it's like, which way do I go, right? So we moved up 7, and then we're going to move east 1, 2, 3, 4, 5, 6. So there it is. And so this here is looking at a township, right? So township is made up of those 36 sections, okay? And this is the way they're numbered. It's a little bit weird, but you always start in the northeast corner, so that's number 1. And then you move across, and then you move back, and then it gets, so it's this weird kind of like if you stuck a snake in a box, right? And just like, it's kind of coiled in there. So that's the way it works. For whatever reason, they decided to use that system. And so now we're going to zoom into a section. So we started off with a township, and then we looked at all the sections. Now we're looking at within an individual section here, right? This is the northwest quarter. This is the northeast quarter. This is the southeast quarter, southwest quarter there. And this figure here kind of gives you a breakdown of how these all work, right? So we start off with our principal meridian, right? So this would be our initial point. Then how do we describe what township we're in? Does anyone remember? So we started off here, and we want to describe where, for instance, this is. So we need to kind of move up the township, right, and over the range. So we get that township 3 north, range 4 east. And then we have our section here, so we're in section 24. And so we're going to get even finer scale. So this location here, right? So we've got section is 24, and then we're within this section. You notice this box here, that's the northwest quarter, right? And then this would be the northeast quarter of that. And so when you use your legal description, you actually start at your most zoomed in scale, and then you zoom out, right? So right here we're looking at, this is the northeast quarter of the northwest quarter, right? Of section 24, we see that right there. Township, so now where are we in reference to our initial point? We're township 3 north, we're at range 4 east, and what was our initial point? It's the Willamette Meridian. So you kind of see how it all kind of is described from all these reference points. Stephen?
Do you know why the subdivisions and the sections are different sizes, different area sizes?
So you're describing kind of these things in here?
Yeah.
Yeah, so I imagine that when land was first divided, you know, land was bought and sold when people were going to the frontier, you had these large areas, right, that were being sold to people, maybe a whole township, something like that. But then as land starts, you know, being sold into smaller parcels, we keep breaking these things down into smaller and smaller areas. And so you get down into things like, yeah, well now we want to know what the northeast quarter of the northwest quarter is, you know. And then within that, nowadays, so what, we know that this is a section, right, so it'd be 1 square mile. And so, this would be 1/4 mile by a quarter mile, right? And I'm not sure what that comes out to acreage, but you can be sure that properties bought and sold in smaller than quarter mile by quarter mile, So it gets even smaller than that. You know what I mean? So,
Yeah, so if the northeast quarter is 160 acres, it means that one is 40.
say that again?
The outlined in red
Yes.
is gonna be like 40 acres, correct?
Okay, yeah, so I guess here, yeah, so 160 acres, so a quarter of that, yeah, you're right, 40 acres, yeah. Yep. So 40 acres is a sizable property, yeah. And so I think it mentioned in the lecture, the federal government, they survey things down to quarter sections, but once you go smaller than that, that's usually done privately, yeah. So, and so here it is. We have the northeast quarter of the northwest quarter of section 24, right? Section 24 here. Township 3 north, up 3. Range 3 east. What's our initial point? What is all of this in reference to? To the Willamette Meridian there. And so then finally we'll just to remind you, the reason that some of those meridians that we looked at before, that they're disjunct and things like that, when we're applying the 2-dimensional grid system onto something 3-dimensional, all these meridians, they're north-south lines, so where do they meet? There's 2 places on Earth that they all, the poles, yeah, so they all meet at the North Pole and the South Pole, right, and they come around. So if you were to be looking down at the North Pole or the South Pole right below you, and meridians are imaginary lines, you don't actually see them, so you can kind of choose, maybe if you wanted to imagine the Earth's cut into 4 meridians, right? If you look down, you'd see this circle, you could draw whatever size circle you want, and you'd see that it's cut through by 4 lines, right? And so at the equator, these meridians, they're at their widest point. And then as the Earth kind of tapers up towards the top, these meridians are getting more and more narrow, right? And so when we apply this to something like a township here, we've got a whole township, well, it does make an impact. And so down at the bottom here, this is actually where it's going to be its widest, because we're in the northern hemisphere, right? And so down at the southern part of this, it's going to be closest to the equator. That's where it's going to be the widest. Then as you get to the top of that township, it's starting to get a little more narrow. It's tapering with the Earth there, right? And so if you look at this, it's actually, you're actually starting to lose parts of these sections, right? So here's all your sections. And so these sections here are the ones that are trimmed a little bit to kind of correct for that tapering of our meridians. And Tom mentioned in the lecture, I thought it was pretty funny, not to buy land in section 6 because you're losing a little bit on both sides, So yeah, so that's a little reminder that hopefully will be useful for the exercise that you guys do. Sweet, thank you.